It's October 13th, 2022. Today's a really exciting day. I'm here at GTP Motorsports in North Hollywood, California. I'm here with Moto IQ. We have Yurbal, the owner of GTP Motorsports, and his G82 M4. We're gonna be testing our new Level Up S58 intake manifold with built-in charge cooler that we've made with our strategic manufacturing partners, PWR. It's 70 degrees outside, it's perfect boost weather. I'm really excited to see your impressions on the part. It's the first time you've seen it, and get it in a car and see what it does.
The stock manifold's really hard to beat. The Supra had a really small intercooler, and it was really easy for you to package a lot better of an intercooler in there. But this car has a huge intercooler stock. The plastic, I think, is kind of weak, and this should be a big improvement.
The core itself is about 23% bigger than the original. So we're using like a super ultra efficient bar and plate core versus the OEM that has a tube and fin core. The stock boost level on this car is about 15 PSI. Because of EcuTech and other tuning platforms and what people were able to develop with the B58 platform, guys are already pushing 26 PSI, 30 PSI. Right now he's running between 32 and 38 PSI. We're already talking about almost three times the boost levels with this car already.
It's been my experience, like stock plastic manifolds blow up. Where does the stock manifold become a problem where you might blow it up? Well, yours is definitely going to hold together better.
From all the feedback that we've gotten through the community and talking to Yurbal here today, anywhere past like 30, 32 PSI, you're risking the stock manifold basically separating where the core is crimped on to the plastic tank.
That's a typical failure mode.
So with ours being 100% TIG welded, it being CNC billet aluminum, this should be good for 60 PSI plus. This is really kind of future proof for where the market's going to go. Just in the few short years that the B58 motor's been out, how crazy guys are doing at the drag strip, already pushing past that 50 PSI mark. So this thing's ready to go for those levels as well.
The engine's direct injection, but you have provisions for port injection here for taking it to the next level where the stock fuel system can't manage anymore, right?
Yeah, absolutely. So, talking to Yurbal today and just getting a little bit more feedback on what his customers are requesting. The stock car being at 15 PSI, he said guys really start doing secondary port injection at about 26 PSI. It's all built in, ready for that. It comes with everything you need, the fuel rail, all the bolts. You just have to have your own injectors, and we definitely recommend several different brands that work well with this kit. So it's good to go for all the fuel. Today we're going to be running it at 26 PSI with no secondary port injection, just so we can compare the manifolds, just the stock one versus the performance of the CSF. Then we're going to be running 32 PSI with port injection, 38 PSI with port injection, and at that point we're pretty much tapped out at any limitation of the OEM manifold. And then we're going to give it hell and try to do as much as we possibly can, 40, 45 PSI with the CSF, and really see the performance gains and all the advantages and benefits that he wasn't able to get with the OEM manifold.
Is your plenum have more volume?
And not only does it have more volume, with some of the pictures that we're going to roll into the video, you're actually going to see all of the air guides that we've machined on the interior side of the plenum. We've done a really good job with CFD analysis, working with our partners at PWR to really maximize the efficiency and the flow, really make sure everything was optimized when it came to the performance and the airflow of the manifold.
CFD is like a really powerful tool, and it's kind of a step up on what the typical aftermarket does. That gives you a lot more confidence that this is actually going to perform.
The way we've machined the ID of our quick connect fittings to be higher flow, it's a really good full package to get the performance that we're looking for. So I'm really excited to see how it does.
So inlet and outlet pressures are being monitored by the EcuTech, and also our inlet pressure is being also logged by the EcuTech, but there's no way to really log that separately. So what we're doing, you're using an AEM data logger. So we have our AEM pressure sensor here, and we follow the wiring. That's going to take us over to the AM 6-channel CAN bus module. What this does is takes a CAN signal, basically interprets it into a signal that the CD7 dash will be able to read. We also have our cigarette lighter adapter here. This AEM dash we're actually using as kind of like our mobile test system, so whenever we have to test anything, depending on the sensors, we can go ahead and make the changes here. So we'll show you the menus here. So we have our inlet and outlet pressures that we're going to be monitoring here with the dash, but again, we're only doing the outlet pressures for today.
So now, hey, we're back. It's 12:30, 74 degrees, North Hollywood. We're about to get started with the first test. So basically we just did the first run. We targeted 25 PSI, sometimes it goes a little over. He made about 548 horsepower at that. We saw that he lost 2 pounds of pressure through the manifold. So that's the pressure loss as it goes through the intake manifold. So yeah, right now we're just logging everything. We're gonna do 2 more runs. So for every power level, we're gonna do 3. We're gonna take an average. We're really gonna get the right data so we can present that to everybody about how our intake manifold works once we swap it out.
What I really liked about your super manifold was all the attention to detail. You know, like how some of the other manifolds, you'd have to take the manifold off to change the oil filter, and you made sure there was plenty of room to work around things. So I assume that you did all your homework and you put a lot of attention to detail in this manifold too.
Absolutely, and you know, you just mentioned about that recess for the oil filter. It's sitting right here. As this thing sits in the car, we'll be able to get our hand right under, get the oil filter. And you know, a lot of the professional guys, Pro-Am guys who are racing, they really appreciate that because they're changing their oil every time they go to the track. This manifold is a lot more complicated and a little bit harder to install compared to the B58 that sits on top of the engine. The fact that other guys are trying to come out with this and you can't get to the oil filter is a really bad idea and it's a bad design. It's a pain to take this out, and then every time you take it out, you're gonna end up scratching it. So, you know, you don't wanna scratch your nice pretty manifold either.
And so like every boss, every fitting, everything to work is right in there, typical of like all your products.
We really wanted to give it that OEM fit and finish. So we thought about everything from a machine pin that works if you want to run the engine cover to these evap hose line brackets, so the wire sits there, it's not flapping around or moving. Some of this stuff you'll never see when it's installed, but we really want to go that extra, extra mile to give the product all the value that it deserves.
Every single one of your products that I've ever used, from the radiator to whatever, drops right in and has a lot of attention to those little details.
You know, we even try to go as far as how it's come packaged. You know, just like what we did from the Supra, everything comes vacuum bagged, everything's gonna have a letter, it's gonna have all those same similar types of instructions that have diagrams of where everything needs to go. It'll be step-by-step instructions for a DIY guy or any shop who's doing this for the first time. It should be like, no questions asked, how do you install this complicated part as easy as possible? We've done the same thing that we did on our B58 manifold. We've included this parameter pad on the outlet side, the cold side of the manifold, with 3 1/8 MPTs. You can read boost references, you can use it to censor anything that you would like. Another thing that we have is this threaded ORB fitting right here, and there's also another one on this side on the throttle bodies. Not just the M3 and M4, it also fits the F87, X3M, and X4M, and their crankcase position is different. So we've actually included threaded machine fittings that we've made. What you can also do is, if you want, you can use the hose on certain applications and use this as another boost reference. You know, you can run a blow-off valve off this or some other type of reference point with the hose that we supply. Another thing that's pretty cool that we've added on the water side, even though this system is technically self-bleeding, we've actually added a bleeder port. A lot of guys don't know how to run the factory BMW bleeding procedure. Sometimes you have to run it multiple times to really get all the air out. Just having this available, with being able to get in with an Allen key and really make sure the rest of the air is out, I think is another nice, neat touch that we added.
I see you have a heat isolating gasket too.
Absolutely, so if you hand one, I have one out of the plastic bag. So this is something that we've come out with for the B58 manifold as well. It's a thermal rejection spacer. And what you're doing is you're basically separating the metal from the throttle body on the cylinder flange versus the cylinder block. and you're not getting that heat transfer. So this actually now comes standard with this manifold. So we designed it to include, and it comes in the kit. We actually went to an aerospace grade company called KTN Thermodynamics, and it's made out of a proprietary patented material called Kyle-X. The testing that we saw with our B58 manifold, we were getting about 40 to 60 degree intake air temp drops with this installed. This is a huge benefit that we're including with our kit. Don't be fooled by, you know, same color or same design. This is definitely a very technical part that we've worked with, you know, some very great people on. Here with Raphael, he's our new engineering assistant. So Ralph has been really instrumental in working with PWR to make sure that we can get the CAD files designed, you know, revisions done efficiently. So check out what we've been doing. So that was our official first test. We're targeting 25 PSI, 593 horsepower, 490.8 torque. That's 25 PSI with increased timing, no port injection. So that's gonna be our first test. It's about 12:45 in the afternoon, 75 degrees outside. So we're gonna do that test a couple times, get an average reading. Then we're gonna do a heat soak test, and then we're gonna increase the boost. 12 runs for the OEM, then we're gonna swap to the CSF, and then do all those tests again. These are 1/8 NPTs. That, you know, and we're just thinking about the future, what guys are gonna be wanting to do later down the line. So on the back side of this manifold, you can do individual meth or nitrous control. They come plugged, and you know, they're just there, so if a guy wants to run nitrous, he can run that as well. We just finished the first 3 tests at 25 PSI testing, no port injection. And to be honest and be completely transparent, the stock intake manifold is actually working really well. Only about a 9 degree Fahrenheit difference in intake air temps. And we're gonna raise the boost now to 32 PSI. About 3:30 right now. I'm here with Yorbel, owner of GTP Motorsports. He was the one doing the dyno testing. Actually pleasantly surprised to see how well the stock manifold does perform. You know, a lot of guys are you know, starting to have it fail at around 30, 32 PSI and a little bit more. You were able to do a glory run all the way up to about 40 PSI, but it does look like it lost a lot of boost pressure at the very end of the top.
Yeah, it looks like in intake manifold, like after 6,000 RPM, it's losing like a lot of boost. Maybe it's squeezing somewhere. We will inspect it later, see what's going on over there. But it's not run to run. It's like not constant. One run, it's like keeping the boost. Next run is just losing. We don't know, so we will check it.
Some issues with the stock manifold, but you were making about 840 horsepower.
Yeah, rounded numbers.
On his dynamite, so good numbers. And now we're gonna put ours on there, the CSF manifold, and we're gonna see how it does. We're definitely gonna be doing all the same testing that you just saw, and then we're gonna see if we can start passing past 40 PSI. So really, you know, this is a product for guys who want the reliability, want to do super high horsepower, and we're gonna see what it can do. We just pulled off the stock manifold. We have it side by side with the CSF by PWR manifold. The stock manifold did pretty well. I mean, the car made like almost 840 horsepower on this dynamite. I'm really excited to see now what this is gonna do, knowing how much more efficient this core is compared to this one.
Super obvious that that core is bigger. You can see there's more plenum volume, like through here. These are the crimps that fail, right?
Yeah, and you know what we were seeing at about 40 PSI, we were getting really irregular boost, right? Like sometimes it would be fine, sometimes it would lose a ton of pressure at the top end.
So you think it was
there's obviously air and boost pressure coming out from somewhere. Now that it's irregular, you don't know if the seal's popping, you don't know where it is, because you know intermittent problems are the hardest ones to chase. We're not worried about that with the CSF one. We're really excited to see what it's about to do. You know, with these plastic end tanks, you know, for a system that's designed to be 15 PSI, you start to get to 40, it's not really designed to do that.
It's just like the radiator where there's an O-ring in there, and then this whole thing blows out.
You know, the provisions on ours is all there. You know, even this this clip that sits right here, once we pop it off, is going to fit right onto this. So even for all the brackets and wires, you know, we have all the clips and rotations and everything like that. So we've really thought of everything for this part. We're going to plug the rest of the ports that we need. We're going to put the port injection on here. We're going to put all the provisions that needed to be run on this car, and we're going to get this in.
Yeah. Sorry, where's the stock?
So we just installed the CSF by PWR manifold. Everything went in just like it's supposed to. Engine cover's back on. That's even installed with the fuel rail. So you can run port injection and continue to run your engine cover, which is exclusive to our design. Right now, Yorbil is just filling up the coolant. We're gonna run factory bleeding procedure 1 or twice just to make sure that all the air is out. And we're gonna start the testing. We're gonna do the same testing just to kind of compare pressure loss across the core. We were getting about 1.5 to 2 pounds on the stock manifold. We wanna see what the new bar and plate core is getting. And at that point, we're gonna do 1 run of each at 25 pounds without pore injection, 32, then we're gonna go up to 40. And at that point, we're gonna start building on that. So where we stopped with the stock manifold, we're gonna continue to move forward with the CSF. So that's where we're at right now. As you can see with it installed, yeah, it looks great. You know, you're gonna get all the boost and all the looks. Because the OEM manifold actually held up and did pretty well, why don't we just start the CSF manifold testing at where we left off. So we're gonna start back at 40 PSI, and then we're gonna build from there. We'll do 40, 42, 44, and move forward. And let's see how much better this can do, how much more boost pressure this can hold than the stock manifold. .840 horsepower, so that's only at 40 pounds of boost. So yeah, we're already going higher horsepower than we were earlier. That just looked easy. So we're gonna start going up from here. So we just did our second run with the CSF PWR manifold. We were targeting 42 pounds of boost. We hit 42.3. We just did 850 horsepower on the dyno. So we're climbing, the car feels good, it's strong. We're super confident about the reliability of the manifold. We're not gonna blow it. So I think it's only up from here. So the next step is gonna be 44, and let's see what it can do.
The compressor efficiency is rolling up.
843.
Right now we're gonna do a heat soak test. We're basically gonna do a bunch of 20 to 130 pulls. So we're gonna do 10 of them. 40 pounds of boost. He's gonna rip it up to 130. He's gonna let it naturally come back down to 20. He's gonna rip it again. And we're gonna do that 10 times. And we're gonna be measuring starting and ending intake air temps, just to show you guys how good the recovery of the intercooler manifold is. So we just finished our heat soak recovery test, and we just got through 6 runs, fried the brakes. Engine cooling was super high temps, and drivetrain limp mode loss is what we got. But intake air temps were super consistent throughout every test. It went from 40 to 43 Celsius. So basically you're going from 104 to 110 degrees intake air temps Fahrenheit, and it didn't move, it was pegged the entire time. So coolers is definitely working. You're not getting this like rising intake air temperature as you do repeated runs. The recovery is really good. It's coming right back down to where it started, and that's the type of performance we're looking. You're gonna get repeatable, measurable performance with the CSF intercooler. So, you know, that kind of concludes where we're at today. I wish we had bigger turbo on the car so we could really start to max out where it's going, but, you know, guys with X-Drive, guys doing upgraded turbos, guys who are going to be pushing 45 to 50 plus PSI, this is the part you need. I mean, we've seen it throughout the industry. Guys are doing 32 PSI on their stock manifolds, they're blowing. Somehow we were able to get to 38, 40 PSI on a stock manifold, but that's not common. So if you're a guy who wants to do big boost, you want the durability and reliability from your manifold, you're gonna need to get the CSF by PWR. It is now available. You can catch the debut at SEMA, and we're really excited about this. Thanks for watching.